Hi friends, today we are going to discuss about the feature scaling techniques in machine learning. So today topics are the what is the feature scaling and why do we require the feature scaling and different feature scaling techniques. So here four different feature scaling techniques are existed: min-max scaler, standard scaler, normalizer and binarizer. So first we have to discuss about the what is feature scaling. So here feature scaling is one of the important pre-processing of the data. So before creating the machine learning model, we have to require the pre-processing. So what is the pre-processing techniques? So under pre-processing, there are the some of the techniques like data scale and imputation and categorical to categorical to categorical to numerical. So conversion. So these are the pre-processing techniques. So under the pre-processing techniques, the data scaling is one of the important. So under the data scaling, some of the techniques are there: min-max scaler, standard scaler, and normalizer and binarizer. So these are the feature scaling techniques. So feature scaling is one of the important of the pre-processing of the data. So before creating the machine learning model, it is necessary. So for standardization or the normalization of the input data for the machine learning. So scaling can make difference between the weak machine learning and strong machine learning. So means depends upon the scaling, we have to decide is it the good machine learning or the weak machine learning. So most common techniques of the feature scaling are the normalization or the standardization. So why do we require feature scaling? So feature scaling is required for correct prediction and results. So here, in case when the values of one of the column is very high compared to the others, which means the impact of the columns with the higher values will be much higher compared to the impact of the low value columns. So which means, so in this data set, for example, there are the two columns. So in the two columns, there is a one column name is experience, some another name is salary. So experience 5 years, 10 years. So salary is 50,000 and this is 70,000, like that. So here every feature has the every feature values has the two things. Feature values, two things. What are the two things? First one is the magnitude. Second one is the units. So experience we have to calculate in the form of units is years, salary in the form of rupees. So here the values is nothing but the magnitude and the year and rupees, and there are the units. So every feature, so experience is one kind of feature, salary is one more feature. So this experience feature has the units, we have to use the year, and salary is the feature we have to consider in the units rupees. So the values belongs to the magnitude. So every feature values has the two things, magnitude and units. So here feature scaling is required to correct predictions and values, which means here, so here for example in experience there are the two digit numbers. The number of years is 5, experience is 5 and 10, but say experience salary is one more feature, this is the 5 digit number. So here this salary feature has the more impact compared to this lower impact value. So that is the meaning of the sentence. So here one of the columns is very high compared to the other columns. So this salary column is very high compared to this experience. So hence the prediction might not give the expected results. So if you suppose the same data you have to apply feed to the model. So the model will give the wrong results, which means this model may not give the expected results. It may fail for satisfying the our business use cases. So that's why according to the model we have to we have to apply the scaling. So scaling is important in the algorithms such that support vector machines and k-nearest neighbors. These are the some of the machine learning algorithms. Here these are the algorithms we have to use the distance. We have to apply the Euclidean distances. So we have to apply the Euclidean distance and to find the distance between the data points. This is the important in this kind of algorithm. So in this kind of KNN and SPM machine learning models, so scaling is very important. For example, the data set containing the price of the products. So without scaling, suppose they are not applying the scaling. So at that moment the model, so model is here, so example SPM. So SPM may treat the $1 equal to 1 Indian rupees. So here for example like that here sorry, so actually we know $1 is equal to about 74 rupees, but the model it may consider $1 is equal to 1 Indian rupees. So without scaling, this is the kind of scenario may happen. So at that time, so here, so gradient based algorithms. So gradient based algorithms like machine learning algorithms like linear regression and logistic regression and neural networks. So in this is the algorithms. This is the algorithms use the gradient descent. It is an optimization technique to require the data scale. For example, if you take the linear regression, so linear regression requires two feature scaling. So this linear regression require feature scaling. Why? Because so in linear regression, for example, y is equal to mx plus b. So here m and b are the coefficients. So these are the coefficients of this linear regression. So the coefficients of the linear regression we have to find with the help of the gradient descent algorithm. So for example, in this kind of scenario, gradient descent, so this is the curve. So in this curve, this is the global minima. So this is the global minima. So suppose if you not apply the feature scaling, so data points means the coefficient values may be far away from the global minimum. So at that moment, so the model like linear regression, it will take time to find out the optimal values, optimal parameters means m and b values. So that's why if you apply the feature scaling, so at that moment of time the coefficients means here b and m, these are the coefficient values will be placed nearby global minima. So at that moment of time, when you apply the linear regression, when you apply the feature scaling in linear regression, at that moment of time, so the model will find the best optimal values. It is very fast compared to the feature scaling. So don't be confused. I will explain again. Suppose this is the gradient descent algorithm. So in gradient descent algorithm, what is the concept? This is the curve. So this is the global minimum. So global minimum. So here in linear regression, what is the formula? Y is equal to mx plus b. So here, so the m and b are the coefficients. If you are apply the feature scaling, so at that moment of time, the m and b values will be placed nearby global minima. So at that time, it will take less time to execute the model. Suppose if you are not apply the feature scaling, what happen? in linear regression, so the coefficient values b and m, it may be far away from the global minima. So at that time it will take time to reach the global minima. So that is the case. So gradient based algorithms like linear regression or logistic regression. So in neural networks, so with the help of the gradient descent optimization techniques, it is required to scaling. Next one, distance based algorithms. So distance based algorithms means KNN, K means support vector machine. So these are the most affected by the range of the features. So these are the algorithms using the distances between the data points. So we have to find the distances between the data points by using the Euclidean distances. So that's why. So these is the three algorithms are the distance based algorithms. So here the machine learning algorithms works on the numbers. So machine learning algorithms works on the numbers and does not know what the number represents. So for example, a weight of 10 grams and price of $10, it represents the completely different two things. As a humans, we know this 10 grams is the one kind of feature, $10 is one kind of feature. Both are two different things, but there is no relation between these two features. But model may consider as if both are the same. So another example, we have the age and salary in this table. So age cannot have meaningful comparison to the salary. There is no comparison between the age and experience salary. But the model may assume that salary is greater than the age. So that's why model will give the more important to the salary. So feature scaling is required. Why? Because so regression coefficient is directly influenced by the scale of features. So this is the point we already discussed. So which means so in the gradient descent, so if you find out the global minima, so if you apply the feature scaling in regression coefficient, it will take less time to execute and will give the results very fast. So features with higher scale dominates the lower scale features, which means that if you have two features, one feature is experience, one feature is salary. Say experience is the one digit number 257. So salary may be 6-digit number 50,000, 70,000. So here features of higher scale magnitude. So this feature salary is the one feature. This feature has to dominate this experience feature. So point 3. So gradient descent can be achieved easily if we have scaling levels. So means if you apply the feature scaling on the gradient based algorithms like linear regression neural networks, so in this time it will take less time to execute very easily. So some of the algorithms would reduce the execution time if scaled. So some of the algorithms means if you see in linear regression kind of things, if you apply the scaling on the linear regression, it will take less time. It will reduce the execution time. If you are not apply the feature scaling in linear regression at that moment of time, so this linear regression will take the time. It will take the more time for execution. So that's why if you apply the scaling, it will reduce the execution. If you are not supposed to apply this scaling, it will take time. So some of the algorithms are used Euclidean distance based metrics. So Euclidean distance based means KNN. So K means clustering, SVM. So these are the algorithms find the distance between the data points with the help of the Euclidean distance. So some of the examples of the algorithms where feature scaling is required, where feature scaling is not required. So in point number 1, so K nearest neighbor, which is the Euclidean distance based matrix. So here it should be scaled for all features to weight equally. So here in this kind of algorithm, so in KNN algorithm, we are using the Euclidean distance based measures is sensitive to magnitudes and it should be scaled. So all values should be scaled for all features. So point number 2, we can speed up the gradient descent by scaling. If you apply the scaling on the gradient based algorithms like linear regression, so at that time, so we have to speed up. So tree based models are not distance based models and handle varying range of features. So scaling is not required while modeling the trees. So in tree based models, so decision tree, random forest, XGBoost, this kind of techniques, we no need to apply the feature scaling. And performing the feature scaling on linear discriminant analysis and naive-Bayes algorithm may not have much effect. So these are some of the algorithms, so which are the feature scaling is required. So different feature scaling techniques. So we can use the different scaling techniques in order to scale the input data. So we will use the scikit-learn library to demonstrate the various feature scaling techniques. So min-max scaler, standard scaler, normalizer, binarizer. So first we will discuss about the min-max scaler. So what is min-max scaler? So this scaler shrinks the data within the range -1 to +1 if the negative values. So and also we can set the range between 0 to 1. So what is the formula for min-max scaler? So this is the formula: x nu equal to xi minus minimum of x divided by maximum of x minus minimum of x. So here this x nu, it is the normalized value, and max x minimum x, so this is the maximum x and minimum of x, means maximum and minimum of these features respectively. For example, if you take the data set, so in this data set this is the experience and this is the salary. So in this salary, for example, experience of 5 to 1, this is 20,000, this is 10,000, this is 5,000. For example, 3 by 2, 3 rows, 2 columns. So in this, for example, this experience is the, we consider the x. So in the x, this you have to consider the xi is the 5, and the among this, in this feature, what is the maximum value? 5, minimum value 1, and this is the which value we are supposed to consider is equal to 1, 2, 3, like that. So I will explain in practical, don't be bothered. So when the value of xi, so when the value of xi is the minimum value in the column, so when the minimum value in the column, for example, xi is equal to 1, so the numerator will be 0, so this value will be 0, and hence the x nu will be 0. So whenever the xi value is minimum value, so at that moment of time the normalized value will be 0, and when xi value is maximum value, so suppose this value is maximum, for example here 5, so at that moment of time the numerator is equal to the denominator, so hence the value of x nu is equal to 1. So here when xi is equal to minimum value, so at that time then x nu is equal to 0. When xi is equal to maximum value, then x nu is equal to 1. So which means the xi value between the minimum and maximum, so which means the x nu value, this x nu value between the zeros and 1. So that is the range of between the, that is the range of the min-max scaler. So min-max scaler used in deep learning like image processing and convolution neural networks. So in this kind of algorithms we are supposed to apply the min-max scaler. Suppose if you see the image processing, in image processing we are supposed to apply the in convolution neural network. If you take the images data, in the images data, if you take the pixel values, so those values are between the range 0 to 255. So we have to apply the unit vector, you have to apply the unit scaling. So if you apply the unit scaling, so the values between 0 to 255 we have to convert between the 0 to 1. So at that moment of time we have to apply the min-max scaler. So if you see the practical, if you take the here I am considering the simple dataset, that is the diabetes dataset. So if you I'm reading the diabetes dataset, if you take the head part, so these are the features: pregnancy, glucose and blood pressure and skin thickness, insulin, BMI, and up to these features are input features and this is output feature is the target feature. So this dataset shape is 768 rows and 9 columns. If you see one, this is the pregnancy 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this dataset shape is the 768 rows and 9 columns. If you apply the feature min-max scalar, so what is the formula for min-max scalar? Xi minus Xi minimum by X maximum minus X minimum. So for that purpose, we have to apply the from scalar and pre-processing import the min-max scalar. So after that, this is my dataset head part. So here what I am doing, I can divide the entire dataset into two parts. So X and Y. So this is my input feature, this is my Y. So here X means, if you see here only 8 features, if you see Y only target feature. So here I am applying the minimax scalar on the range between 0 to 1. So this we create the one object scalar. So this scalar dot fit transform, I am passing the this input values. So this input values, that's why X is given here. So here print the transform data. So this is my scaling data, scale down the data from this data can be converted into like this. So how can you convert? Let's see the formula. So this is the formula. So what is the formula here? So formula is equal to X new is equal to Xi minus minimum of X by maximum of X minus minimum of X. So this is the formula. So here, suppose here I am taking the, this is in pregnancy column, we have to calculate the, we have to consider how this value came from 0.3529 from this value. So this value can be converted into like this. So how can we convert it? By using this formula. So in this formula, so if you apply this df.describe, so this function will give the statistical information of the data set. So what is the statistical information? So count, so how many observations? So 768 observations. What is the mean value? What is the standard deviation? What is the minimum number? What is the maximum number? What is the 25th percentile, 50th percentile, 75th percentile? So here, if you see, if you apply these values, so here the Xi value I am considering this 6 and minimum of X. So what is the, for pregnancy column, what is the minimum value? This is the minimum value is 0, maximum is 17. So minimum value is 0 and maximum value is 17 and minimum 0 means 16 by 17. So 16 by 17, if you see here, this is a 6 minus 0, this is 6 minus 0. So this is the 6 minus 0 and this is the Xi value and this is the maximum, this is the minimum. If you execute this statement, say 0.3529, 0.3529, this value is same to this value 3529. So which means this under the pregnancy feature, this 6 will be converted into 6 will be rescaled down to 0.3529. Suppose if I apply the one more feature, so now I will convert this value 148 under the glucose feature. Under the glucose feature, the value will be 148. How this 148 will be converted into 0.7437? So let's see. So at glucose feature, the minimum value will be 0. So under the glucose feature, the minimum value will be 0 and maximum value will be 199. So if you apply the formula 148 minus 0, 199 minus 0, so 0.7437, 0.7437. So both are same. So this is the way we have to scale down the data into the min-max scalar. So next, standard scalar. So in standard scalar, so standardization is another scaling technique where the values are centered around the mean with the unit standard deviation. So this means that the mean of the attribute becomes the 0 and resultant distribution has the unit standard deviation. So means here in the standard scalar, the data will be distributed like this, normal distribution. So in this normal distribution, here mean will be 0 and the first standard deviation, this is the first standard deviation and this is the second standard deviation and this is the third standard deviation. So this is the first standard deviation and this is the second standard deviation and this is the third standard deviation. So here this is the x value and this is the mean value and this is the standard deviation. So transform the data such that resulting distribution of the mean 0, mean value 0 and the standard deviation is 1. So mean will be represented with the mu symbol and sigma is equal to 1 is represent the standard deviation. So this kind of technique, standard scalar, mainly used in k-nearest neighbor and k-means clustering algorithms. If you apply the standard scalar, this is the formula z is equal to xi minus mu by sigma. So I am importing this library standard scalar. So I am importing the standard scalar, creating the library scalar. So scalar dot fit, I will passing the x value. So x values means these are the input values up to here. 8 attributes I am passing here like min-max scalar. After that I am transform the x and I will see the result. So this is the scaling values after applying the standard scalar. So how can you apply the standard scalar? So this is the formula. So if you see the df describe, okay. So here I am applying the formula. Formula is equal to z is equal to xi minus mu by standard deviation. So xi means here considering the 6 pregnancy value 6. So 6 minus what is the under the pregnancy, what is the mean value? So this is the mean value 3.845. So this is the mean value x 3.845 something. Standard deviation, this is the standard deviation 3.369. If you calculate this value, what is the value supposed to get? So 0.6395. So this is the value supposed to get. You can compare this value. So here see what is the value got 0.6395 0.6399. So this value is approximately 0.6399. This value is approximately this value. Suppose if you want to see the, if you want to check this value, how this value will be converted. 148 will be converted into 0.8483. So here the xi value will be 148. So xi value is 148 and the mean of the glucose. So what is the mean of the glucose? 120.89. So 120.89. So standard deviation 31.97. 31.97. If you execute this value, say 0.8477, which is the value is same to the 0.8483. So in this way we are supposed to calculate the standard scalar. Next, normalizer. So this is the third one. So normalization is a rescaling of the data from original range so that all values within the range from 0 to 1. So normalization is a good technique to use when you do not know the distribution. So here the main important point is when we supposed to apply the normalization. When we supposed to apply normalization, when you do not know the distribution of your data. So distribution means, suppose if you know that, if you came to know your distribution of data is not a Gaussian distribution. So Gaussian distribution means what is that meaning? Bell curve. This is the Gaussian distribution. So this is the Gaussian distribution, another name bell curve. So bell curve, here this is the standard mu is equal to mean value is equal to 0. So this is the first standard deviation, this is the second standard deviation, this is the third standard deviation. So it means here the data will be distributed in the bell curve. So if when you know the distribution is not Gaussian, so when the data is not be distributed in the Gaussian, so at that moment of time you are supposed to apply the normalization. So normalization is useful when your data is varying scales. When the data is in different scales, at that moment of time you are supposed to apply the normalization. If you see the practical normalization, so what is the formula? Xi by root of xi square plus yi square plus zi square. So I am importing the normalizer from SQL and pre-processing. Import the normalizer. Next normalizer, I have to create the one object scalar. So I fit the input data and transform the input data. So this is the values. This is the normalized data. So how to convert this data? This is the x data. So in this data, this 6 will be converted into 0.036, and this 148 will be converted into 0.8276. This 72 will be converted into 0.4026. So means suppose at x is equal, suppose here I am considering the x is equal to pregnancy. So at the 0th observation means the values means 768 rows. The rows will be start from 0. So means this is the 0th observation. So this is the 0th observation. This is the first observation. Means row number 0, row number 1, row number 2, like that. So at the 0th observation, so xi value will be 6. So here we substitute this formula. So this is the formula. So in this formula, this xi value is 6. 6 divided by root of 6 square plus 148 whole square, 148 whole square plus 72 whole square plus 35 whole square plus 0 square plus 33.6 whole square plus 0.627 whole square plus 50 whole square, this value. So if you find this value, you got the value. So if you see, here this is the 6 means xi, np dot square root of 6 square plus 148 whole square plus 72 square 35 square 0 square 33.6 square 0.627 square 50 square. So these are the input features. So these all input features we have considered the. So this is the xi square, y square, z square, like that. So means according to formula xi by root of xi square plus y square plus z square. So root of xi square, y square, z square, like that. So you will get the 0.37, 0.335. So means this value is approximately 0.0336. So this is the value is here. This is the same value. So this is the way you are supposed to get the values. So if you check one more example, so at glucose feature, so at the glucose feature, 0th observation xi is equal to 148. This is 148. So how the 148 becomes 0.8276? So 148 divided by root of 6 square, same. So 0.8276, it is equal to 0.8276. So this value is about the same. So at x is equal to age feature. So suppose if you see this value, so this value means this value 0.2796. You see 50 by, so 0.2976, 0.2976. So this is the way we are supposed to calculate the normalized scaling values. Next, binarization. So feature binarization is the process of thresholding numerical features to get the Boolean values, or in other hand, assign the Boolean values. So means true or false for each sample based on a threshold. So here, so binarization is mainly based on the threshold values. So the binary values is supposed to replace by 0. So means all the values which are greater than or equal to 0, the values 0 is replaced by the threshold value. So the values which are less than the threshold value you can replace with the 0. If more than the threshold value, replace with the 1. That's why this binarization, this is called the binarizing our data or the thresholding our data. So both are same. So it can be useful when you have the probabilities how you want to make the crisp values. So it is useful when feature engineering and you want to add one new feature, so that indicates something meaningful. So in feature engineering, when you are supposed to add the one more feature, so at that moment of time, this binarization is also be useful. So if you see the binarization, so same process from SQL and pre-processing, import the binarizer, scalar, fit transform. See the all values between the 0 to 1. So means the threshold value is less than or equal to 0. So which means that in the binarization you can set the threshold value. The values means the probabilities values is less than 0, less than or equal to the threshold value. Means if you here in binarization you get this some probabilistic values. So these values are these are less than or equal to some threshold value, for example 0.5 or 0.6 like that. So those values here replaced with 0. The probabilistic values is greater than or the threshold value 0.6, for example, we may replace with 1. So when it is less than or equal to 0, replace with 0, and is greater than or equal to when greater than threshold value, it replace with the 1. So this is the binarization scaling techniques. So this is the whole concept of the feature scaling. So here I'm using some references. So if you have any kind of doubts and if you have any kind of comments, please give in comment section. Thank you.